the whole expectation for high-speed internet on a luxury vessel or even a large charter program has just completely changed the game.
Oh, absolutely.
We're talking about yachts running out of these busy hubs like Fort Lauderdale or spending the summer in the Bahamas. Connectivity isn't just a perk anymore.
No, it's mission critical. I mean, the days of just accepting those, intermittent, super low bandwidth VS connections are just, they're over.
Yeah.
Captains, engineers, ETOs, they're all demanding something that feels like fiber, but at sea.
Right. So that's what we're digging into today. We've got this fantastic, really practical guide on the current state of Starlink Maritime.
We're focusing specifically on the plans, the specialized hardware, and I think most importantly, the installation details you need for real high-throughput operations.
And what I like about this source material is it just cuts right through all the marketing hype. It gets to the, the technical and the financial reality of it.
Yeah.
The core tech we're looking at is Starlink Maritime, which relies on that big constellation of LEO low Earth orbit satellites.
And that's really what's unlocked this whole thing. You get global ocean coverage, and crucially, you get genuine high-speed use while you're in motion.
So our mission for you today is pretty simple. We're giving you the shortcut.
We are. We're going to unpack these global priority plans, which are, well, they're non-negotiable for marine use, and then we'll dive into the hardware.
Specifically that surprisingly rugged Gen 3 flat high-performance antenna.
The one that can actually survive life at sea.
Okay, so let's unpack this, starting with the plans, the cost. We hear this term everywhere, global priority. Why can't a vessel just, grab a cheaper residential plan or an RV plan and call it a day?
Well, global priority is Starlink's enterprise-grade service, and it's mandatory for really two big reasons: mobility and reliability. It's designed for global coverage, so it works in international waters, it works across borders on land. For a business like a yacht, that's essential. And it also gives you a few tech advantages, like a public IP address, a dedicated dashboard for management.
But I think the most important part of that is the guarantee, the reliability guarantee they offer.
Absolutely. That's the SLA level availability. SLA, that stands for Service Level Agreement.
Right.
So Starlink is basically guaranteeing a minimum level of performance and uptime. It's not just a best effort residential service. It's business grade, which is what you need for operational continuity on a charter.
That makes a ton of sense. The reliability alone is worth the premium. Now let's talk money. The sources show Starlink has simplified things recently, shifting to these block-based plans. Does that make life easier or harder for, say, a chief engineer?
I'd say it simplifies it as long as the crew is proactive about matching the plan to their actual use. They've gotten rid of a lot of the complex roaming rules. Now it's just clear data blocks. You buy a certain amount. We're talking tiers that start pretty low, like 50 gigabytes, but they scale way up, 500 gigs, a terabyte, 2 terabytes, and even bigger enterprise options.
So what's the entry point? If a vessel is just dipping its toes in, what's that baseline cost look like?
It's actually pretty accessible considering the performance. That smallest 50 gigabyte plan runs in the neighborhood of, say, $250 to $265 a month. But of course, it scales up fast. A busy charter yacht might need that 1 terabyte tier, which could be around $1,000 a month, maybe more.
Okay, and this is where it gets really interesting and, frankly, a bit stressful for the ETO.
Yeah.
The overage dilemma.
Yes.
When a vessel burns through its data block, let's say they use up 500 gigs 3 weeks into a busy month, they have to have made a choice ahead of time, right?
That is the single most important budgeting decision you'll make in the Starlink interface. It determines whether you get a massive surprise bill or whether your internet just stops working.
So let's walk through those two options. What happens if the captain decides to opt in for overages?
If you opt in, you keep your full high-speed performance no matter how much data you use. But the catch is the cost.
Right.
You immediately start racking up overage fees. Right now, that's running about $2 per gigabyte.
Wow.
So if you burn through an extra 100 gigs in one busy week, that's an extra $200 on your bill. It's performance assurance, but you have to budget for that risk.
That is a very steep price for streaming Netflix if you're not paying attention. Okay, so what about option 2, the protective one? Opting out of overages.
If you opt out, the moment you hit your data limit, Starlink throttles your connection hard.
And what does that mean?
You get free unlimited data for the rest of the month, which sounds good, but your speeds are crushed. The source material specifies a throttle down to 1 megabit per second download and 0.5 up.
Wait, 1 megabit per second? If you've just been enjoying a super fast connection, hitting 1 megabit with a boat full of guests must be agonizing.
It's crippling, truly.
I mean, that's barely enough for a single email, let alone, navigation updates or critical uploads.
Forget about it. You can't stream, you can't sync large files, you can't even have multiple people browsing the web comfortably. If that happens mid-charter, the operational fallout is, well, it's severe.
So the complexity isn't just the price, it's matching the plan to your risk tolerance speed versus budget.
Exactly. You're managing a dynamic risk. If you know you have a high demand charter coming up, it is always cheaper to temporarily boost your plan for that month than to get hit with surprise overages or angry guests on a 1 Mbps connection.
That overage risk is daunting, but let's shift to the hardware. Because none of this matters if the gear can't survive out there.
Mm-hmm.
When we talk about Starlink for marine use, we're really only looking at one specific kit, the Starlink Performance, or what they call the Flat High Performance Gen 3 antenna. Why does this model matter so much?
Because the Gen 3 hardware is, well, it's purpose-built and it's rugged. Unlike a traditional VSAT dish that has to physically move to track a satellite.
Right, with all the motors and gears.
Exactly. This is a fixed, electronically steered phased array. There are 0 moving parts. And when you're on a vessel with constant vibration and movement, getting rid of moving parts is a massive win for reliability.
Okay, what about durability? Salt spray, tropical heat, green water over the deck. The specs in the sources sound almost military grade.
They're seriously impressive. The Gen 3 dish is rated for survivable winds over 170 miles per hour. That's deep into hurricane territory.
Wow.
And it handles huge temperature swings operating from -40°C all the way up to +60°C.
But the spec that really jumps out, the one that separates it from consumer electronics, is the water sealing.
That's the one. IP68, IP69K. Now, this isn't just splash-proof. IP69K is a specific rating that means it can resist close-range, high-pressure, high-temperature water jets.
So you can literally pressure wash it.
You can pressure wash the deck, hose it down with salt water, and the hardware is engineered to survive that direct contact. It's an absolute necessity for open deck mounting.
That really tells you this isn't just some adapted tech. It was designed for this kind of industrial resilience.
Mm-hmm.
From a performance angle, does the design help when the vessel is actually moving?
It does, dynamically. The performance array has a very wide 140-degree field of view.
Okay.
And when a vessel is moving at speed, it has to constantly hand off the connection from one satellite to the next as they fly overhead. That huge field of view is critical for maintaining an uninterrupted connection during those handoffs.
So fewer dropouts when you're running fast.
Exactly.
Most people think Starlink is just plug and play, but the sources are really clear that a marine install, especially with this fixed Gen 3 hardware, is very different.
Oh, absolutely.
The ETO can't just bolt it down flat anywhere on the hardtop.
No, and ignoring the orientation rules is probably the #1 cause of poor performance on boats. The alignment of that fixed wedge mount is absolutely critical.
So why is it so different from just putting one on your house roof? What happens if you just bolt it down flat?
You immediately compromise the system. 2 reasons: water management and sky view. The mechanical reason first. The wedge mount it comes with has a built-in tilt, maybe 8 to 12 degrees.
Right.
You have to use that. It's engineered to shed water, so you don't get pools forming on the dish face, which can kill the signal.
Okay, so you've got the tilt, but the direction of the tilt is the most important rule, right?
That is the crucial orientation rule. It's simple. The lower edge of the antenna must be pointed away from the biggest potential obstruction.
So on most boats, that means pointing it outboard.
On the vast majority of vessels, yes. Point the lower edge toward the outboard side, keeping it clear of the superstructure, the mast, other domes, you name it.
Why does that matter so much? Why the lower edge specifically?
Because these LEO satellites are lower on the horizon when they rise and set. If that lower edge is pointed right at a big mast, the mast will block the line of sight and cause constant momentary signal losses, we call them dropouts. By pointing it outboard, you maximize that clean view to the horizon.
And I saw a specific tip for high-speed boats, like a planing yacht doing 30 knots.
Yeah, for high-speed vessels, the advice is to point the lower edge forward toward the bow. This likely just optimizes the dish's electronic view relative to the vessel's movement and where it's looking for the next satellite.
And regardless of where it's pointed, there's a universal rule about a clear sky view. What's the non-negotiable there?
You have to preserve a completely clear 360-degree view of the sky at an elevation of about 20 degrees or higher.
So you have to be really careful about where you place it.
extremely meticulous. You can't put it right under a big radar or next to an exhaust stack. That 20-degree mark is where a lot of the satellite traffic happens.
And how does the crew actually check this? Once it's bolted down, you can't see the satellites.
You verify it digitally. The Starlink app has a dedicated alignment tool.
Okay.
It uses your phone's camera with augmented reality to show you the sky path, and it will give you a specific warning if the physical mount is off by 5 degrees or more. It's an essential tool for commissioning the system.
And just a quick note on the wiring side of things.
Yes, compliance is key here. Use proper marine-grade cabling. Don't rely on the consumer-grade wires it comes with for a permanent install.
Right.
Use proper backing plates to distribute the load, and route the power cable with drip loops and UV protection. Basic marine best practices.
Okay, so Starlink is the gold standard offshore. But things change when you get near land. Let's talk about the modern hybrid strategy.
Yeah.
Blending Starlink with LTE and 5G. Why not just stick with Starlink everywhere?
Well, it comes down to optimizing for cost and performance. When you're nearshore docked in Fort Lauderdale, anchored in the Keys' local LTE and 5G networks often have lower latency.
And they're cheaper.
And crucially, much cheaper. Bulk data on a local SIM card is almost always significantly cheaper per gigabyte than Starlink Global Priority data.
So, nearshore, 5G wins on cost and latency. Offshore, Starlink wins on reach. How do you manage that transition? You don't want someone manually switching systems every time you leave port.
No, ideally it's all automated. This is where you use a specialized piece of hardware, a multi-WAN router or a blending router.
Okay.
It uses what's called policy-based routing. The router decides the best path for your data based on rules you set: cost, latency, or even just your geographic location.
So give me a practical example. How does that policy work?
Sure. Let's say the yacht is docked. The router is programmed to send all the general traffic streaming crew internet over the active 5G SIM card because it's the cheapest path.
And Starlink?
Starlink is kept on standby, maybe only used for a specific critical system. But as soon as the yacht sails, say 20 miles offshore, the 5G signal degrades. The router detects that and automatically, seamlessly shifts all the traffic over to Starlink.
That's the definition of a resilient, cost-aware network.
Exactly.
And on the budgeting side, how do captains avoid hitting that painful throttle point or those massive $2 a gig overage fees?
It's a three-pronged approach. First is the human element. You have to track your usage. Use the Starlink app and the metrics in your onboard router to figure out your baseline and watch for spikes.
And the second, the technology strategy.
Keep that nearshore LTE 5G SIM active. Use it to offload as much data as you can whenever you're at the dock or at anchor. Every gigabyte you use on a cheap 5G plan is one you didn't have to buy from your expensive Starlink block.
That could be a huge saving.
It is. If you save 100 gigs while fueling up, that's $200 you just saved on potential overages.
And finally, what's the strategy for those really high-demand times, like a busy charter week?
Simple forecasting. If you know a heavy usage period is coming, don't just hope for the best and rely on overages. The smart move is to temporarily step up to a higher data tier for that specific month before you need it.
So go from 500 gigs to a terabyte for August, for example.
Exactly. It gives you predictable pricing for that high capacity.
So what does this all mean for the operator trying to finalize their connectivity plan? Feels like we've covered 4 critical pillars here.
I think so.
1, the global priority plans are all block-based. You have to actively manage that overage choice to balance cost versus performance.
2, the hardware is tough, but only that Gen 3 performance dish really meets the standard for extreme marine durability. You have to have that IP69K sealing.
3, installation is not simple. You have to nail the wedge mount orientation lower edge away from obstructions and keep that 20-degree sky clearance. And always verify with the alignment tool.
And 4, for real resilience and budget control, you need a hybrid network. You blend Starlink offshore with cost-effective LTE 5G nearshore, and you use a smart router to manage it all automatically.
Fantastic. It's just so clear that good maritime connectivity has gone from being a luxury to a totally mission-critical tool.
That really is the ultimate takeaway here. It impacts everything: navigation, safety, guest experience, even maintenance. And given that, having a single point of failure in your network is it's unacceptable today.
And that leads us perfectly to our final provocative thought for you to consider as you're planning your next refit. If reliable internet is now essential for every single part of your operation, how would incorporating a secondary LEO option, like OneWeb, which we often see paired with Starlink on larger super yachts, how would that fundamentally change the resilience of your operations at sea?
Something to think about as redundancy becomes the new normal.